Now that we've pretty much wrapped up the unit, we're going to look at application problems with these trig identities, which is just word problems. So how to use those same steps to set up the problem and then solve it. Always start these problems out, if they don't give you one, by drawing a picture. It makes it easier to see what your angle of interest is, and what sides you're trying to find. So more specifically, you should be drawing a right triangle. All of your pictures should include that. Okay. Read the story problem and then label your triangle. With your given information, so your angle of interest, the sides that they give you, and all of that. Decide which trig ratio that you need to use in order to solve for the indicated value, and set up the problem. By writing some sort of equation. All right, solve and round your answer appropriately. Okay, so make sure you read the directions as to what to round it to, and make sure your answer makes sense within the context of the problem. Also label your solution. So feet, centimeters, degrees, whatever it is that you're trying to solve for, make sure you label it appropriately. All right, so let's look at a problem here. So we have a ladder leans against a building. So here's the building, here's the ladder. The top of the ladder reaches a point on the building which is 8 feet above the ground. So I label as I go here, but I notice that it's 8 feet above the ground. So if this is the ground, then from here to here is 8 feet. Right. The foot of the ladder is 7 feet from the building. So again, here's the building, here's the foot of the ladder. So that distance from there to there is 7 feet. It doesn't say anything about how long the ladder itself is. So I'm not going to label that. Okay. Find to the nearest degree the angle at which the ladder makes with the ground. And the reason that this is important, and it's not necessarily math you would do yourself, but somebody had to at one point in time do the math here to make sure that this angle would be safe if put up against a wall this high, for somebody to use. So the ladder meets the ground right here, so this is your angle. This is what we call an angle of incline because we're looking up. So if we look straight out and then if we look up, it forms that angle. All right, so we have our angle, we have our triangle, we have everything labeled. We need to look, we want to find this degree here. So we're using one of our inverse ratios. So in terms of this angle, we need to label the sides. So this side, in terms of that angle, would be opposite. And then this side here is adjacent. So when you think about your trig functions, the one that uses opposite adjacent is tangent. So I can write my equation, tangent of theta is equal to the opposite, which is 8, over the adjacent, which is 7. Remember, to solve for this, we're then going to take the inverse tangent of both sides so that those cancel, and we have theta is equal to the inverse tangent of 8 over 7. Let me type that in our calculator. So I'm getting 48.8 nearest degree. I'd round that up to about 49 degrees. All right, so any questions about that, make sure you jot them down so that you can ask. Right? An airplane climbs at an angle of 18 degrees with the ground. So we know this is going to be a right triangle. Our airplane is going up, right? This angle right here with the ground is 18 degrees. Find the ground distance the plane travels as it moves 2,500 meters through the air. So it's looking for this distance here. It's telling us the plane itself, so you have like your little airplane flying through the air. It has covered a distance of 2,500 meters. So that's this distance that the plane has actually gone. It wants to know how far, if we were driving underneath it, would that actually be, the ground distance. And we don't know the height or its altitude either. But there's your right triangle that it forms. Right. So what we do know, 18 would be our angle of interest because that's the only angle we have. Remember, you could always find this angle also by just taking 90 minus 18. So you could easily switch your angle if you want to use a different trig function. We are going to round to the nearest 100 meters. So keep that in mind as well. In terms of what we are given here, we have our hypotenuse. It's across from our 90. It's our longest side of our triangle. We're looking for this length here. Well, that is our adjacent. It touches the angle. So our adjacent is x. Think about all your trig functions. The one that uses hypotenuse and adjacent is cosine, being the ratio adjacent over hypotenuse. So we set up our equation and we say the cosine of our angle, and remember an angle measure always goes with the trig function here, is equal to your adjacent, which we don't know, over your hypotenuse, which is 2,500. All right. So we can then multiply by 2,500 on both sides. And in our calculator, we would just type 2,500 cosine 18, and that would give us an approximation for x. So when I'm typing that in, I'm getting 2377.64. It wants me to round to the nearest 100 meters. Well, my hundreds position is here, and so I look behind that, and so it's approximately 2,400 meters. So make sure you round accurately. All right, a guy wire reaches. A guy wire is like the big wires you see telephone poles down to the ground. A guy wire reaches from the top of a 120-meter television transmitter tower to the ground. So if this were our tower, imagine it's straight. Your guy wire goes from the top to the ground. Right? We know that the tower is 120. It will be perpendicular with the ground. The wire makes an angle of 63 degrees with the ground, so there's our 90. With the ground here would be 63 degrees. Find the length of the guy wire to the nearest meter. So we're looking for the length of the wire. All right. So once again, we label our triangle. So in terms of our angle of interest, that is opposite. This is across from the right angle, so it is hypotenuse. Pick your trig function and solve for x. All right, so go ahead and set up your equation and solve for x. I'm going to pause the video, so I want you to do the same and then work it out. Okay, here are the steps for this problem, rounding to the nearest meter at the end. Okay, a 15-meter pole is leaning against a wall, so you have your wall, you have your pole. We know the pole is 15 meters. Right, so you can label as you go. A 15-meter pole is leaning against the wall, so this would be the pole, this will be the wall. All right. The foot of the pole, the foot would be down here, is 10 meters from the wall. So if it's 10 meters from the wall, this is 10. It forms a 90 with the wall. Find the angle the pole makes with the ground to the nearest tenth. So a lot of these are having us find this angle down here as our angle of interest. Just be careful that you don't always assume that is the angle, because it could say just as easily, find the angle the pole makes with the wall instead of with the ground. All right, so that's your theta. Go ahead and set this problem up to solve for theta. Remember that we are finding an angle, we're going to use an inverse function to solve that. All right. So go ahead and push pause and try that now. Alright, so again we're using the inverse of that, so we take the inverse of both sides. Theta is approximately 48.19. It wants it to the nearest tenth, so that's going to go up, so 48.2 degrees. Alright, so again watching your labels. The last two I'm going to have you try on your own, but I want to talk about one thing real quick. You'll see these terms angle of elevation and angle of depression. The terminology sounds different, but it's doing the same thing. So an angle of elevation, I kind of talked about earlier, it'd be like if you were standing and looking straight ahead. That's your direct line of sight. Well, and then you avert your attention upwards, and so it creates this angle inside here that's called your angle of elevation. So again, we'll call this theta. Theta is your angle of elevation. All right, so when you're drawing your right triangle, there's your right triangle. Okay. We will even talk about how, like, okay, well, if it's this far off the ground, we have to make sure we add that height back in. This one is not going to have you do that. So don't worry about that right yet. All right. And then your angle of depression would be like if you're standing up high, so again you have your direct line of sight, and now you're looking down, and you're looking down at the water or something. It creates again that right triangle, but that angle of depression is inside that one. Okay. So it would be going down this time. So there's theta. The picture's a lot smaller here. theta is your angle of depression. Right. So from the top of a tower that's 80 feet high, all right, those ones are kind of different. So we have the tower itself is 80, but we're looking down from the top of it. So here's our direct line of sight. Here's us looking down. It's talking about this angle right here. Okay. All right. So good luck with those. Give them a good go. And we will go over them tomorrow in class. Have a good night.